Tonight, we have Hedera Hashgraph in the building, so I'm kind of stoked about that. Let's give them a round of applause real quick. So I'm with Mousebell. We're a full-service blockchain accelerator, focused on early-stage startups, investing in them. And we have a large engineering team. That team that we've been together for, over 5 years now. So our core focus is really kind of contributing to the ecosystem and adding value on our end as much as we can through development, kind of building projects, products, incubating teams, and trying to do as much as we can on that front. And so recently, we decided to kind of come full circle. You know, I've been going to meetups a lot, and it's kind of slowed down here in the Bay over the last few months. And talking to Galen, our CTO, which will be up here shortly, decided to do some tech talks and kind of have fun with it and kind of give our perspective with some of our network and friends that we've met over the last couple of years, and we've gone to develop a relationship with Hedera and thought, hey, let's bring them in, and kind of host this discussion and kind of get their insights and understand their perspective and have fun with it. So with that being said, I'll go ahead and introduce Galen. He's my CTO. He's been in the space a long time, and I'll go ahead and let him give a brief
on. All right, so I'm Galen. I'm the CTO of Mousebell. We want to get a few more of the just sort of tech talks in the area going in the blockchain space. So we reached out to Hashgraph, and they're happy to join in. So we've got Greg here, who's going to tell us a little bit more about the product he's working on and what they're up to as it's getting closer to launch.
Yeah, hi everybody. Closer to launch. Greg Scullard from Hedera Hashgraph. I'm actually based in Europe, out in France, which is where I live. And I happened by Brazil last week to meet one of our council members. We'll talk a bit more about that later on. And I thought maybe coming over to see my Californian colleagues would be a good idea. And here I am talking to you guys. So I'm glad to have you here, and let's hope that we can cover some stuff that's of interest to you guys. So thanks for the invitation.
Yeah, happy to have you. So to get things kicked off, just a couple of questions.
Don't worry about it.
Has anyone here heard of Hashgraph before? You've got a show of hands. And does anybody own any HBAR right now? All right, we got some people here. So I guess Greg, you want to start off, give like a quick introduction to Hashgraph?
Sure thing. So Hashgraph was born, strangely enough, as a consensus engine, or consensus algorithm way back when. It's been worked on for many, many years. It's been proven in the private domain, the private space, through a company called Swells that deployed the algorithm in a private setting. And the idea was very much to try it out and test it out with those private enterprises before going mainstream, going public, with the public implementation of the Hashgraph algorithm, which we call Hedera Hashgraph. So Hedera itself is an LLC based in Delaware, which is made of, or will be made, up of 39 council members. There are sort of owners or part owners, if you want, of the LLC, and those council members essentially become the stewards of Hedera Hashgraph moving forwards, looking at all of the technical governance, the legal governance, and so on and so forth. The algorithm itself was invented by Dr. Lehman Baird, our chief scientist, and his goal was to look for a consensus algorithm that could scale and remain secure and be fast. So we now have an algorithm that we call fast, fair, and secure. Pretty unique in this space as far as we're concerned, and we make no, we give nothing away to security or anything else. A lot of people talk about the trilemma of blockchain, or distributed technology where you have to give in to security in order to increase throughput, or you have to give in to governance in order to increase the other two. With Hedera Hashgraph, we believe that we've achieved the best of all three without making any sacrifices on the way.
So compared to other distributed ledger technologies, there must be in the hundreds now. What do you think that Hashgraph is really trying to solve? What's really unique about it?
So when I'm out and about talking to prospective council members and existing council members or DApp developers, we talk about Hedera superpowers, the things that we believe nobody else does in the industry. And one of those is what we call a fair timestamp. And we'll maybe talk into more detail about the consensus algorithm itself, but essentially every transaction on the system is, when it reaches consensus, is given a fair timestamp. And if all of you in this room were to independently agree on the time at which we're having this talk, then that would be a fair timestamp. If you were to a piece of paper and then get everyone to validate that you've written it down, it's not a fair timestamp, you can skew it. So fair timestamps is one of our superpowers, pretty unique, if not unique altogether. We also, from this timestamp, can derive fair ordering. So the order of transactions as they are witnessed by the network is guaranteed to be fair. Nobody can alter, or no node can unfairly alter the order of transactions. There is no leader that can front run or front load a transaction with their own. They can't decide to exclude a transaction. Or if they do, as a user, you have mitigations that you can send a transaction to other nodes. And therefore one single node cannot unduly affect this order. We have another superpower, which is our security, asynchronous byzantine fault tolerance, which is a gold standard in public distributed ledgers. And as far as we know, we aren't the only ones that have this property. We are the only ones who have proven it through formal methods. So those are the things that stand us out compared to other ledgers.
Okay, so you mentioned asynchronous VFT. Can you dive into a little bit more about how the Hashgraph consensus works exactly?
Sure. So let's just imagine that we're all nodes, right, in this network. Or let's imagine we're nodes in a different network. Typically, transactions would be collected by miners, and miners would win, or a leader would be elected by the network, and would bundle those transactions into a block, and then broadcast it to the rest of the network for validation. With Hedera Hashgraph, it's somewhat different. So going back to, we're all nodes in a network, and I'm the client, and I send you a transaction. You will gossip that transaction as a node to the rest of the network. So it's just like social media to a certain extent. You tell a friend, hey, I've heard this really good information from Greg. And this friend will then gossip it to someone else. And before you know it, and you will carry on gossiping at the same time. So before you know it, in a few rounds of gossip, this entire room knows what I've told you. So that's the first step, is distributing this information to everyone. And notice there is no leader in this process. Nobody is making a decision on behalf of the others for validation. The other part of the gossip protocol that Lehman's implemented is what we call gossip about gossip. So when you tell Wes, because I know your name over there, that you've heard this information from me, Wes knows you've heard it from me. So he knows that you know it, and he knows that I know it because you told him, even though I've not spoken to him. When he talks to anybody else in the room, he'll do the same thing. I've heard it from Galen, who heard it from Greg. So very quickly, the entire network knows exactly who knows what. And attached to that is a piece of information, which is a timestamp, which is when you heard this information. So within seconds, everyone knows who knows about this information, this message, this event, or this transaction, I should say, and when everybody on the network heard of that transaction. And at that point, mathematically speaking, everyone can make a determination of what we call the median time. So we take all the times everyone's heard of this information. We take the one that's nearest the middle, that's our fair timestamp. And everyone in the entire room has their copy of the graph, this conversation that's been going on, and they independently, asynchronously, can come to the conclusion, which is consensus. So they can say, hey, 2/3 of the network heard of this particular transaction. And we'll talk about staking later on, but looking at stake, they can say the majority or the super majority of the network agrees this transaction is valid. Therefore, we can put it into the ledger, so we'll apply to state. You can take 1/3 of the network out. Gossip will carry on, consensus will carry on going on, as long as it's less than 1/3. You can take one node out, you can DDoS it. Everything will carry on going on. So that's how Hashgraph is different.
Oh, absolutely. So it sounds like everything is done in async, and there's not a sense of a block, whether a single block producer produces a block, everyone validates it. So this is completely different in that sense from delegated BFT then.
Yes, absolutely. As a node, I'm sat there listening to transactions from the client side, and I'm also listening to events coming from the network. And when I receive an event from you as a node, if I have some transactions to bundle into an event, I create an event in my line of the graph. If you see the hash graph, it kind of looks like vertical lines and dots and lines across the verticals. I create an event in my line to commemorate my conversation with you, and that's my opportunity to pull transactions I have in my queue, put them into my event, and then broadcast that event to somebody else in the room. And therefore, my transactions are part of this event, which is kind of a block, but this is only for the duration of consensus. Once we've reached consensus, we don't need to retain those blocks or those events. They're no longer necessary for consensus.
And for the timing mechanism used there, say if I were to own 10 HBAR and I send 2 transactions for 6 HBAR, whichever one of those was received second and acknowledged by the network wouldn't be possible since I don't have the sufficient funds. All of that, is that determined internally? Is there a concept of like an order, like an IOTA?
No, not at all. It's entirely determined internally by every single node. So the algorithm is deterministic in that when a node reaches consensus on a particular, or calculates consensus on a particular transaction, it knows, and this has been mathematically proven, that all of the other nodes will have reached exactly the same conclusion. So, and this, honestly, it took me a while to get my head around it when I first joined just over a year ago. I couldn't believe this was possible. We have all these disparate computers, talking to each other, and they're running this independent program, and they're messaging stuff around each other. And when you look at it, given a tiny time difference, at some point in time, they all agree on everything, and therefore they could maintain their local states. They can update your balance or decrease your balance by 6 when the first transaction hits the network or reaches consensus. Your balance is decremented on every single node. At that point, I can ask any node, what's your balance? And they'll tell me 4, because you have 10. When your second transaction reaches consensus, every node looks at your new balance, it's 4, you haven't got enough. It gets rejected. As a client, you get notification to say insufficient balance.
Absolutely. So I understand that you guys also did a bit on the network layer of Hashgraph. Would you be able to elaborate there?
So what do you mean specifically on the network layer?
In terms of discovery of nodes, passing around messages.
Right, okay. So initially we are permissioned, which means that for a few years we will only be running nodes that belong to council members. But the discovery will essentially, as far as I understand it, be a transaction to the network. So as a node, you'll be sending a transaction to the network saying, I would like to join your network, please. And the network will update its address book as a result of that transaction. Every node will receive the same transaction, so every node is therefore able to update its address book. And from that point on, they know you've just joined, right? Because it's been spread around extremely efficiently and very, very quickly. So from that point on, they can start gossiping to you, and they can start expecting gossip from you.
Oh, very cool.
So I guess the address book is updated by virtue of a transaction and is therefore done on chain.
So you just have a distributed set of validators or parties involved.
They're not so much validators. If you join the network, you send a transaction to say, I would like to join your network, please. The address book gets updated, your IP address and your keys, your public key is part of that address book. They can start, every node can start validating events that you send, that you signed with your private key. They have your public key, therefore they know that your events are kosher. And from that point on, you're participating in gossip. They have your balance, which is what we use for proof of stake calculation. So knowing your balance enables every node to make a determination on how much your vote weighs in relation to all the other nodes of the network.
All right, and on the topic of validators, how are transactions validated on Hashgraph?
So the validation is almost it's on a per event basis rather than on a per transaction basis. So remember, an event contains multiple transactions, and the event reaches consensus. The transactions are then applied to state. So the validation is really this this calculation of a supermajority of nodes having seen the event that contains a particular transaction. Validating the signatures that are attached to those events. So events have a hash of the previous events in the horizontal, in the vertical, and a hash of the other events, which is the events that kind of resulted in the creation of that new event. Those hashes are signed and validated, or can be validated. So every node knows when it receives an event that it's a genuine event, because all the signatures match, all the hashes match to their own hash graph. Nobody could introduce an event in the network without having that chain of custody of hashes. So that's the validation that occurs. But as I said, every single one of us here as a node performs this validation in real time as transactions are coming into the network. It's not a broadcast validate, rebroadcast validate, broadcast validate, or compose broadcast validate.
Definitely. So I guess moving into the next topic about the governance council. So what is the governance council, and who exactly is part of it?
So the governance council will be, it's not there yet, 39 of the top Fortune 100, Fortune 500 companies worldwide. So the selection criteria, if you want, is based on two main criteria. One is industry. So we're looking for 18 different industry verticals. So right now we have telecommunications with Deutsche Telekom, Swisscom, and Tata Communication that was announced yesterday. We have legal with the LA Piper, which is a worldwide law firm, first, second in the world, depending on how you look at it. We have a bank with Nomura Bank in Japan. We have a Brazilian company, Magazine Luiza, that is in e-commerce. So if you think of the Amazon of Brazil, it's Magazine Luiza, and they have stores as well. We have, who else? I need to be careful not to forget anyone. We announced IBM yesterday as a council member. So again, they're in a different industry vertical. And yeah, so apologies to council members, I may have forgotten. So we're looking for different industries, and why? Because if they're all bankers or if they're all insurance players, then their decisions would be targeted at making the network work best for their industry, right? I mean, that makes sense. With 18 different industry verticals and no more than 2 or 3 per segment, we can ensure that the banks will keep the telecoms in check, will keep the aeronautics in check, and so on and so forth. So that gives us a balanced view of how the network should operate and how the network should change over a period of time. So that's the first thing. Distribution of, or varying industries, 18 different verticals. Then we'll look at continents and geography. We want to make sure that those council members don't all come from North America or don't all come from Europe. So I've mentioned Brazil, I've mentioned Japan, Germany, Switzerland, DNA Piper, I think is US based.
No, London.
No, UK based?
UK.
Yeah, UK based, my apologies. So all of these guys are on different continents as well. They respond to different governments, or they answer to different governments. So this gives us a level of decentralization in terms of geography, in terms of industry. And they will be the movers and shakers for Hedera moving forwards. We have, with the council members we have today, we've already set up multiple steering committees or working groups. So we have a technical working group that meets on a regular basis. And these meetings are face-to-face as well as virtual through conference calling and so on. And those council members are putting forward their best technical people to help us, help Hedera, I want to say help us, help Hedera decide how to best evolve the platform moving forwards, taking into account market demands and so on and so forth. It'll be the same with legal, it'll be the same with finance, it will be the same across the board. We'll have lots of different working groups.
So is this council just a digital organization, or do you have a physical corporation set up for it?
So there is an LLC in Delaware that they all have to sort of buy into. Through the council membership requires them to pay $100 to be members of the LLC or partners in the LLC. I'm not sure about the exact legal terms here, so bear with me. And when they leave the council, that $100 gets refunded to them. So it's just a small stake in the LLC, so to speak. Sorry, what was the rest of your question?
Oh, I was just asking the structure of it.
Right, yeah, so thank you. It's physical. They meet quarterly. We've had a meeting in Seoul in Korea, when the council members were first announced. They met recently again in New York, and there's another meeting planned in September. In fact, the council members have asked to meet more regularly than we initially anticipated, and that shows just how keen they are to participate in the governance.
Okay. And in terms of the council governance, because this is always an interesting topic, is there any members accountable if a member is acting strangely or maliciously?
So I think by virtue of the fact that these companies are public companies, if IBM were to do something detrimental to the network, their image might suffer. So there's a sense that maybe because they have a brand to protect, they will be doing things in the right way rather than doing things that are necessarily detrimental to the network or people at large. So self-protection in some respects. The other thing is that they are multi-billion-dollar companies. So profiteering from the network will not be their priority. Whatever money, if any, they make from running a node will be inconsequential compared to their revenues. So their interest is really to run the network properly so that their image is maintained. And I should point out and be clear on the fact that they're council members, but they're not given any coin by Hedera for being council members. They are given stewardship of the treasury. They can make decisions as a group through majority voting, but none of the council members can walk away with a slice or share of the treasury. So in some respects, they're the poorest HBAR holders. As council members, the only way they could be rich with HBAR is if they actually acquire it outside of being a council member.
Okay. And then moving on a little bit from the governance council, I know that you also have a proxy staking mechanism set up in terms of staking and rewards on the blockchain. Could you elaborate a little bit about how proxy staking works?
Sure. So I mentioned earlier that nodes are looking for supermajority of nodes having heard heard of a particular event. That supermajority, unlike what I've read in various places, is not based on node count. So if we are in this public setting of Hedera Hashgraph and we're all nodes, we're not all voting with the same weight when it comes to calculating 2/3 majority or supermajority. That voting weight is determined by stake. So stake is two things. The first is how much is in the account, how much H-bar is in the account of the node that is participating in the network. So that's your own kind of wallet contents, if you want. Then, as a non-node operator, if I like a particular node, or if I want to help participate in consensus, I can stake my H-bar to a node. And I have a choice as a user of the network. I can move my stake from node to node on a daily basis if I want to. It's entirely up to me who I stake it to. And in fact, if a node turns out to be malicious, or I don't like what one of the council members has decided, although it's a majority decision, I can decide to withdraw my stake from them and give it to another node. Now, why would I do that? Well, the nodes will earn H-bar for being participants in the network, for receiving your transactions, for gossiping it, for performing consensus, for storing files and so on. They will earn some H-bar. And a part of that H-bar is essentially their profit, if you want. And they have the ability to split that with stakers. So as a wallet holder, if you stake to a particular node, that node can essentially redistribute part of its earnings back to you as a proxy staker, which means that not only are you participating in consensus and you're helping the network stay secure, you're also getting something back from the network in the form of interest, rather than having your H-bar sit there do nothing at all. Now, so that is that different to other networks? I don't know. What is very different to other networks is that we don't slash. So if a node is misbehaving, you don't lose your stake. Even if you are a node and you're misbehaving, you don't lose your stake. Although misbehaving will probably require you to spend H-bar in the first place. But staking to a node has no slashing properties. There's no bonding either. You can carry on spending or earning H-bar while you're staking. The network calculates the rewards proportional to your stake. So if you spend all your H-bar in the day, then at the end of the day your rewards will be less. And if contrary, you earn a lot of H-bar, then your rewards will go up as a result. So it's an entirely fair staking mechanism. We encourage people to stake as much as possible.
Oh, yeah, that's very cool. Is there any concept, or have you seen anything in the community related to staking pools? Would a staking pool be useful at all with proxy staking on your network?
So, only malicious, I think. I mean, as an individual, you can stake to a node and you can earn rewards or returns, so to speak. If you joined a pool, you'd be one of many who stake to a given node and have to then divide all the earnings back into the number of participants. So, unlike other blockchains where you have to amass a certain quantity of stake in order to be able to run a node, almost kind of buying your spot in the network, with Hedera, even if you have one H-bar, you can stake it, and it would be no different whether you do it by yourself or whether you do it as a pool. So I guess the only place where I would see a pool forming is where a group of individuals would want to put all of their stake onto a single node and try and get some sort of control over consensus. That can't happen for several years, by the way, because the council will hold more than 2/3 of coins in treasury, so nobody can acquire that elusive 1/3 that would stop the network from reaching consensus. They could not corrupt consensus, and that's an important property of the network. So I don't think there's any need for pools. I don't see any need for pools.
And I want to move on a little bit onto smart contracts now. So how do smart contracts on Hashgraph work?
Just like another famous platform, we use Solidity for smart contracts. So you can take your smart contracts across, your Solidity smart contracts across to Hedera, take the bytecode, upload it to Hedera, deploy your smart contract, and it will run. There are some tiny differences in the way we, in as much as we don't have blocks, so there are variables in Solidity like block complexity, block timestamp. Ignore block timestamp. Block complexity, block height, we don't have a value for because we don't have blocks. So we replace those with a fixed value, so the contract execution remains deterministic. Block timestamp is the consensus timestamp of the transaction that carries the smart contract function. So it just works seamlessly. We've had people take existing contracts and migrate them to Hedera in no time at all.
Cool. So are you guys running a full EVM when you're changing state and running all these operations?
So for processing, yes, but then there's some back-end tweaks to make it work with the Hedera states and consensus.
Oh, very cool. So another thing that I've seen in EVE is they'll rely on IPFS for storing files or larger objects. And there's become like a whole suite of tools like that, or Whisper for messaging. Does Hashgraph have any equivalents to this?
Yes, absolutely, and for more than just smart contracts. So we have a file service, so I should have said this earlier. Hedera has cryptocurrency as a native service, a file service, and smart contract, which we've just talked about. So the file service is indeed used by Hedera in the same way that you mentioned with IPFS, where you upload your compiled bytecode to Hedera as a file, and then when you contract the smart contract, you refer to that file, and a copy of that file is made and lives with the smart contract. So any changes, well, I've mentioned changes, it's DLT shouldn't change. Any changes to original bytecode won't affect running smart contracts. So I just mentioned change and mutability, and this is one of the properties of the Hedera Hashgraph file system, and indeed smart contracts. Files on Hedera Hashgraph are protected with public-private keys, just like a crypto account. Subject to having the keys, or the private key for a given file, once you've uploaded a file to Hedera, you can make changes to it, you can change the contents, and you can even delete it. And we guarantee that within the Hedera network, when you've asked for a file to be deleted, it will be removed from all the nodes. It will not exist anywhere else on the network. And we can give you proof. Now, that's an important property, maybe a superpower, whereby a lot of the enterprise customers that we talk to are basically saying, well, we'd like to store stuff on Hedera Hashgraph, but we have customers who will want us to delete that data. How do we deal with that? And we tell them, well, you can delete it, and we can prove to you that information was deleted. So we have our own file system. It's not like IPFS in as much as every node has a copy of the file. It's not a distributed peer-to-peer or N+1 backup type of system. So every node has a copy of the file. And once the file is stored on the network, you can ask any of the nodes on the network for a copy, and they'll gladly give it to you.
So when you're storing all of those files or performing all of those state mutations, how do you pay for that? In Ethereum, I see a concept of gas or many other public chains. Is there something equivalent on Hashgraph?
Absolutely. So all transactions are paid for in HBAR, which is our native currency, whether that's a crypto payment or file storage. In the context of smart contracts, specifically, the specifics of Hedera are somewhat different to Ethereum, as you mentioned there. First of all, the gas price, which is the multiplier, if you want, between our currency, HBAR, and gas, is fixed for every node on the network. There is currently no capacity for a node to say, I'll be twice as expensive as this other one. So that's the first difference. The other difference is that because of the fairness properties of Hedera Hashgraph, we can't prioritize execution of a particular contract based on how much gas was put against the execution. So I'm afraid that those who are able to pay more to get priority processing by a miner on Ethereum can't have that benefit on Hedera Hashgraph. It's whichever of subject to sufficient gas being paid, it's whichever of the 1, 2, 3, 4, 5, 10 transactions for the same contract has reached consensus first to get processed in order. And any overpaid gas gets refunded to the caller. So if you put 1 million gas for something that requires 2, you will not get priority processing, and you'll get your million minus 1, minus 2, minus the cost of processing the transaction back into your account.
Okay, so if there's no sense of paying more for priority, how do you handle spiky traffic on the network?
It will just be processed in series. Is it possible that the queue would be overwhelmed and some transactions would not be processed in time? I guess technically, yes, that's always possible. There's a finite amount of data that we can store in the queue, but there is no. We will not process. We will not give in to fairness. We see this as a critical property for the enterprise or the enterprises of this world to use Hedera Hashgraph. Without fairness, you can't have markets, you can't run a business. It's too unfair.
And while we're on the topic of fees, I wanted to move into rent as well for contracts. Would you be able to elaborate a little bit more on rent, how it's paid?
Sure. So again, I mean, you asked me earlier about the differences between Hedera and Hashgraph. There's so many. One of them, and the rent is one of them, is that we're upfront about the fact that running a network costs. I'm a firm believer that whatever is free for a reason. It's talked about over and over again, but you're the product. So that's one aspect. The other one is somebody is paying for it out of goodwill or otherwise, and at some point that goodwill could disappear. You can't get no guarantees because you're not paying for anything. So, what if those nodes suddenly decided to disappear because there's something shinier somewhere else? So Hedera is being upfront about the fact that running a node, storing data, processing smart contracts has a cost. And as a result, we have a cost table which is available on our website. We will shortly be publishing a calculator, so you can actually go through the website and say, I would like to make a crypto transfer between 5 accounts with six signatures. How much will it cost me? And it will give you a cost in US dollars, as well as in HBAR, because that's what you need to pay. Smart contracts and files have those rent properties from the word go. You create a file on Hedera, you specify how long you want it stored for, and depending on how large the file is, whether it's 20 bytes or 2 megabytes, then a price will be calculated, and if you're willing to pay that price, you can store that file for that time period. After that period of time, let's say 30 days, if you haven't paid to extend, the file will delete. So you're no longer paying rent. I'm afraid we're going to rent the space out to someone else. So the file will get deleted, and the smart contract is very much the same. When a smart contract is created, there is an initial fee for creating the instance of the smart contract. That also creates a crypto account on our platform for the smart contract to hold its currency. And so a smart contract, contrary to a file, because it has an account, has what we call an auto-renew period. So when you create a contract, you give it an auto-renew period, say, of a month. And that means that it will initially be created for a duration of a month, it will be charged for that amount of time. And a month from now, it will renew itself for another month. And it will take the payment from its own account. So you can either Or you can make an API call to say, I would like to extend my contract, and here's HBAR to pay for that extension. So it will either happen automatically, or you can do it on an as-need basis. When that account runs out of funds and the contract is no longer able to refund itself or to renew itself, it will delete itself. Yeah.
So is that deletion immediate? Like if something goes wrong, maybe you forget to fund your account, or you forget to make a payment, your app gets deleted? Is there a way to recover from that?
So for the time being, the answer is yes, you lose everything. We recognize that, and we are looking at ways in which we could maybe store the contract offline for a period of time to allow you to bring it back. But right now, if you don't pay your rent, it disappears once it's gone. And we can give you proof of that.
And for the fees, how are those collected? Are those paid out to the consensus mechanism, the like evenly nodes running it, or are the tokens just burnt?
So they are paid to all of the nodes on the network that participate in consensus. The node receiving the transaction from the client will receive a tiny payment for dealing with that request and essentially validating that it's syntactically correct, which we call a pre-check. Once that pre-check is done, the transaction is sent to the rest of the network for consensus, and therefore all of the nodes participating in consensus at this point will earn a share of the fee that's being paid. My understanding is that share is based on stake, because stake determines the amount that you contribute to consensus. So the higher your stake, the greater proportion of that fee you will receive.
Okay, and I understand that another thing that you guys have coming out pretty recently is the Hedera consensus service. Would you be able to elaborate a little bit more on that? What it is, how it works?
Of course. This is, I'm still getting my head around it most of the time. I'm working on some other things at the moment, so, it's for me, it's groundbreaking. If you think about it, the three services I've talked about so far work on top of the consensus service, and we've made this consensus service available to anyone. So if you don't want to create a file on Hedera, if you don't want to run a smart contract, and if you don't want to perform a crypto transfer, what can you do with Hedera? Well, you can use the consensus service. So let's say, and this is one of the use cases that's currently being worked on by one of our council members, you have a private ledger, a private network, and you want to get validation from a public network of a timestamp, or validation of a higher degree of trust that a public network can give you over and above a private network, which may have a leader, a coordinator, and all these different things. So you can send that transaction over to Hedera's consensus service, and what Hedera will do, so first of all, that transaction can be attached to a topic, and a topic means that every transaction that comes into Hedera's consensus service that's attached to this particular topic will be ordered will be given an order and a consensus timestamp within that particular topic. So if I'm running an app or I'm running a private network and I create my own topic on Hedera Hashgraph and I send all of my transactions into that topic, I will get to see the exact consensus order of all those transactions in that channel or topic. Moreover, I will also see a chain of custody. I will see hashes of the previous transaction in the next one, and so on and so forth. So when I'm listening to events from this particular topic, after they've reached consensus, I can validate that I've not missed a single one of them. So I get an order, I get a timestamp, and I get a kind of my own little blockchain, if you want, of events or transactions within that given topic. So suddenly I can start using Hedera Hashgraph to just transact pretty much anything I want, and there will be a particular message size that you can play with, and you can send it wherever you want, you know, football scores, anything, or baseball scores, or soccer scores, whatever you want, pass it to Hedera, get consensus, and then those clients subscribing to the topics will receive the messages, well, with that kind of internal blockchain, if you want. So it's it's opening up a world of use cases with private-public hybrid networks. It's really exciting.
So with you were mentioning private-public hybrid, how do I handle or how does Hashgraph handle private deployment and public?
So at the moment we aren't working on specific integrations, although I believe that we are working on a Hyperledger plugin, which will make it easy, or bridge that will make it easy for Hyperledger to send transactions over to the Hedera consensus service. I'm not aware that we're working with any other private blockchains to do so, but you know, the API, when available, will be public, and I'm sure that the developer communities and the various private blockchains wanting to leverage the additional trust and fair timestamp you get from a public Hedera network will quickly build the necessary bridges. And
you mentioned Hyperledger. Does this work with other blockchains like public chains, Bitcoin or Ethereum?
Technically, yes. I mean, any system, anyone that wants to, you know, reach out to Hedera and ask for this timestamp and this consensus can do so through the API. So it's up to the other blockchains to deploy that capability in their systems if they want to do so, if they see value in it.
So could I use this to scale out payments in a DApp or transact a token faster as like a layer 2 solution?
Yeah, so layer 2 solution with all the security, the ABFT-ness of Hedera Hashgraph, not a layer 2 solution that's kind of off-chain, so to speak. Absolutely, I mean, we are, you know, internally discussing things where the equivalent of a smart contract can end up running on an application network, which is independent of Hedera Hashgraph. So you get the speed of the Hedera consensus service. It's as fast as our cryptocurrency service, which when we launch before the summer, the end of summer I should say, we'll be able to handle 10,000 transactions per second. So your application network can send its balance change. So, you know, Galen's given me 10 things, whatever token it is. I send that transaction over to the network. I get consensus on it. All of the other apps in the net listening to our topic would see this transaction, update their local ledger, and therefore be in sync with me. And you know, suddenly you have all these apps in these application networks, almost like independent ledgers that are able to run their own software deterministically off a set of messages that have been ordered and reach consensus on a trusted public network. So I think it can fundamentally change a lot of the deployments and speed that we're missing from technologies like smart contracts today.
Okay. So what you're saying is then that you could use something like this. It could be a lightning network for other public chains if you want to say about that.
So I've not looked into it personally, so I wouldn't say yes, but I know that our community is discussing it, is talking about that possibility. So I'll leave it to the community to decide whether that's indeed feasible or not.
So a little bit more on the community. I know that Hashgraph ran a community program earlier this year through the summer. Is that still going on? How did that run?
So it's not going on anymore. It's currently on pause until we may. I mean, we have a budget for community testing, so we may launch additional tests in the future. The purpose of community testing was really to put the network, the main network under some sort of stress, And of course, we could do this in our labs. You know, you can write all sorts of software that will stress a network, but none of these things really relate to real world use cases. So what we did as both as a means to enable testing, but also to demonstrate some of the capabilities of Hedera Hashgraph, is that we put together a website which is not a paywall, but you have to pay a tiny amount of HBAR to view every single article. We've actually written a WordPress plugin, which, if it's not yet, will soon be available from the WordPress App Store or whatever. So if you have a WordPress blog site or whatever, you can install a plugin in there. And when your customers, your users, browse your sites, you can offer some content for free. But if there's some premium content that you want to share, as we did with our demonstration, you can put an article behind a payment, which can be a cent, a tenth of a cent, a hundredth of a cent. We call it micropayment. So would I want to pay 10 cents to look at an interesting article on a newspaper? Of course. That's much better than paying $30 a month or whatever for a subscription. So we've demonstrated that this was feasible. And not only did we do this, but we deployed it on mainnet, so that when you clicked on an article, you paid a tiny amount of HBAR from your account, but we rewarded you back with 5 for each click, up to 250. So this has generated a lot of traffic on the network, which has allowed us to, essentially check that it was able to sustain throughput and so on in a public setting. And it's also helped distribute HBAR to a wide variety of people. I think we're on 10 or 12,000 accounts on mainnet today, and we've not even reached open access yet.
Yeah, that's a pretty cool proof of concept application. Have you seen any other cool ideas come from the Hedera community?
Plenty. So I'm very lucky to be in our Discord channel 20 hours out of 24. But no, frankly, there's loads and loads of stuff, really cool stuff going on there. Decentralized exchanges, wallets, and then we've got, beyond that, we've got some of our DApp partners. So these are companies that have officially announced that they wanted to work with Hedera Hashgraph. So we've had joint marketing campaigns and so on and so forth. So those are, go as far as paying artists for music. You've probably heard of Hero FM. We have a company that's doing microgrids for electricity and using HBAR to pay each other for electricity generation and consumption. Giro, who's their director, did a podcast with us, and he's actually talking about creating containers that can ship to remote locations where they'll be running kind of local IT services and from solar panels and so on. It's mind-boggling what they're doing there. We have stuff in pharmaceuticals. Satara is one of our partners developing today, and they will be looking at traceability of pharmaceutical products. So, and then we've got our council members, and let me tell you, none of those council members are joining just for fun or just because they can sign a letter of intent and go, yeah, we'll kind of do something. They are in it to do something with it, and I've just spent a few days with Magazine Luiza in Brazil just to do that, just to look at what they wanted to do with the network. So I can't wait to see what those big players will do on Hedera. That will be fantastic to see. And just to close on this, we are working actively with some of those early DApp developers. We will have DApps running on the network at OA. The day the network launches publicly, there will be DApps on it.
And when is that network launch going to be?
Can't tell you. You will know soon.
All right, and I've got 2 more before we open it up for questions. These are just sort of fun ones. So what is one thing that you think Hashgraph has done better than any other blockchain protocol out there?
So I think that Lehman's vision for fast, fair, secure is coming to the fore. Like I said, we're not giving into security, we're not giving into performance, and we're not giving into fairness. We're not giving into anything, and we have all three attributes. I was at a conference last year, if I remember correctly, and we were talking about layer 2 solutions for scaling, and I was kind of sat there going, well, yeah, okay, if you have 20 transactions per second, you may need layer 2 solution for scaling. We don't. Sharding is used by a lot of other networks as a means of increasing throughput. Our throughput today is 1 shard, so we'll deploy sharding when we need it, and not just for throughput. So I think we've done that right, and I also think that a lot of our team here from marketing and social. A lot of the feedback that we get is that of a company that's behaving ethically, professionally, and that's something that resonates with me. It's a professional team, and that I think is different to many other, maybe many of the earlier blockchain efforts or the DLT efforts.
Absolutely. And then on the other side of that, what is something that another blockchain has done that you thought that you just wished you thought of or done?
So with hindsight, I come from a developer background. I've developed software for 20-something years, and we've put a lot of focus on the network stability, security, and so on. And while we have 6,000 plus developers in our Discord, which is not a small community by any means, we've not necessarily given them the best tools to get started. So they're doing a great job of deploying to Hedera with the bare bones that we've given them. With hindsight, maybe if we'd given them better tooling to get started, we would be having even more dApps ready to go at open access.
Oh, absolutely. So what kind of tooling do you think that are you planning on adding next?
So certainly on the smart contract side, trying to get to make smart contract deployments easier, and then we're looking at a broader range of SDKs, software development kits. We have Java for now. We're working on JavaScript, and we'll possibly open that up moving forwards. But yeah, so once we're past OA, once we're past the big mountain hurdle, then we can look forward to some work around tooling and so on.
Very cool. Yeah, I think that's one of the things that's really helped get a lot of apps on Ethereum. They have Truffle, they have Remix, they have SDKs in every language. So it'll be very exciting to see once the tooling is all dialed in.
Yeah, so having said that, you can use these tools to develop and test out your Solidity code, and once you've got it working, you can port it across to Hedera.
Definitely clever. So I think that wraps up all that we have for now. But if you guys have any questions, just open it up to the audience.
Spam mitigation. How do you do that? How do you do spam mitigation?
Spam mitigation? In what way?
So if I assume users can use the network cheaply, like how do you prevent them from just sending like a ton of transactions?
So sending a ton of transactions for starters would cost you if they're valid transactions. So in our crypto economics model, the disincentive to attack the network is it will cost you a H-bar to do so. And even a node being malicious would have to pay the rest of the network to accept its malicious transactions. So that's already a disincentive even for a node to kind of internally DDoS if you want. So that's one prevention. The other one is that you would need to essentially DDoS a third of the network and more for consensus to stop. So that would be quite hard to achieve. You can take out 1, 2, 3 through DDoS. The rest of the network will carry on going.
Well, like, so not so much about DDoS, but just spam. I mean, like, Bitcoin, ground to a halt in 2017 because of spam attacks. So, similar thing, if there's a ton of transactions that come through, how do you prioritize things that are important versus spam?
So they won't be prioritized, but the network will process them as fast as it can. And it is possible that, again, technically, it is possible that some of that spam, if it doesn't get processed fast enough, will essentially be returned back to the client as something like, transaction didn't reach consensus in time. So the queue won't build up forever. It will just auto prune if you want. Yeah, we shouldn't suffer from that.
Could you talk more about the council member selection process? And I also read that there's a term limit. So once that term limit is up, and these companies like IBM and Tata, their terms end, like what is the transition process like, and how are members going to be selected?
So very, very good question. So right now, the founders of Hedera are choosing or courting the council members. So we've been through a long period of essentially selling the concept to those early council member adopters. What's interesting now is that with the recent announcements around Hedera and IBM and Tata, we're now seeing some sort of critical mass where council members are now approaching us more directly. Yeah, it's the tables have changed at the prompt, so to speak. So we're having to make that initial selection process. Once the council is established, the council members can only serve a maximum of 2 terms for a maximum of 3 years, after which they can never be council members again. So they could be a member for 3 years, then exit, and then come back for another 3 years, 2 or 3 years down the line. But once they've done their 2 terms, 6th year, they can no longer be council members. Once the council is fully operational, and that means once we have the 39, the council will, the founders of Hedera will become one of the council members with 2.65 voting power. The council as a group will then vote in or accept applications, or will solicit applications, or will go and court prospective council members. So at that point, the 39 will decide who they let in, and it will be entirely governed by the council. And I do believe that even the renewal of the term is subject to council approval.
In the back.
Yeah, help me get around 39 council members, just not too pointed, but it doesn't feel fair or secure. I mean, help me understand that with Ethereum, it's thousands of nodes I can join today, right, and help secure the network. Why are the people you're choosing better? And even more importantly, they can choose themselves eventually. Why is that better?
So it's a fair question. So I guess, yes, anyone can be a node on a lot of those on a lot of the other networks. This will eventually become possible on Hedera. Right now, we are permissioned in the bootstrap phase of the network, simply because the price of HBAR is potentially at its lowest today, or when we launch. It may even be lower still after launch. I can't make predictions, but those things have a tendency to move along on a downward curve before going back up again. But that's by no means investment advice. So in that critical early phase, the network is at risk of somebody buying up all of the supply and taking the network over, or stopping consensus and therefore making the network worthless as a utility network. So in the early days, we want to prevent that clearly from happening. I mean, all this good work would go to waste. So the council members will first have custody of more than 66% of the treasury, which essentially makes an attack on the network impossible. Even if you were to buy the rest of the third, you couldn't take control of the network. Once the council has determined that there is sufficient distribution of HBAR worldwide, they will open up the network to the public to the point where it becomes permissionless. Anyone can join the network and stand up a node and participate in consensus. But we have to bear in mind that we potentially live in a different time to when those other networks started, where there was very little knowledge and they could start, quietly. I guess right now, if we were to be fully permissionless, we are at risk of being under attack by people who perceive us as a threat, and that wouldn't be good for Hedera, clearly. So once the council members are up and running, to your second question, or maybe it was the first, they vote themselves in. Clearly, yes. That is true. You will have Fortune 500s trying to invite Fortune 500s in. But we firmly believe that first of all, no one council member will have more than 2.6% voting power. This is completely equal voting. 100 divided by 39 is around there, 267 or something. So it will be extremely difficult, first of all, for one member to have any significant influence over the others. Again, remember, they have their image to protect as well, so they can't just bend over to the will of one or the other. And even beyond that, it will be extremely hard, because of the cross-industry sort of spread of council members, it'll be hard even for a few of them to gang up on the others and obtain more than 2/3 voting power to drive the network in the wrong direction. So I don't see that as being necessarily a problem moving forward. In fact, I'm more comfortable with large corporates running the network with all the skills, people, both technical, legal, and so on and so forth, that they have, than it's being a more anarchist model. But both can live together. And what I tend to say is, if you don't like the way Hedera is run, there are plenty of other networks that you can use. But on the other hand, if you like the way it's run, then please come and work with us.
Over there?
Yes, I had a whole heap of questions, but
I'm leaving on Thursday.
Yeah, but I guess what they were talking about actually was kind of most interesting for me, because one, you talk about the larger organization component. So my first question is, what's the appropriateness of that kind of approach when you have large organizations who have commonality just by the nature of the way that they service people, trying to decide on the direction of a network, versus that which startups and small organizations, what their desires are out of a network, and not having that same level of voice to be able to direct where this network is growing. What do you see as the long-term ramifications, positive and/or negative, of that? And caveat being, even as you talk about these verticals, if you talk about somebody like IBM, for example, because they do technology and they have a connection to this technological basis, they will, regardless of whatever anybody else industry they're in, they're going to touch on what these other industries do. So therefore, they're not necessarily independent in that regards either. So what is kind of your thought process about that?
So remind me the first part of your question.
So my question is really about the impact of approaching from a large corporation guiding steering committee, the direction, and the expectation that there'll be independent operators and able to direct the network in a way that's beneficial to its users, which aren't necessarily reflective of their same interests.
Right. So thanks for repeating. So first of all, I'd say that a lot of businesses I've worked for Cisco. So those companies take input from their customers and from a lot of the smaller companies, the startups that they work with on a daily basis. They are their customers, they are their partners. So I personally, from my experience, I mean, you might argue that some play the kind of big boys in town and they direct everybody else, but in my experience, generally speaking, they take significant input from community, customers, and so on and so forth. We'll be setting up a developer advocacy group where we will be taking input from the developer community back into Hedera Hashgraph. So we're not, it's not going to be a closed committee. We are respectful of the fact that we have developers and users who will have demands and so on and so forth. It's just that they won't necessarily have a one man, one vote or one node, one vote. The council will make those decisions. Now, I also believe that they will make the right decisions because the health, the value of the network entirely depends on those decisions. And the network is only useful if it's used by lots and lots of people. It only has value if it's used by lots and lots of people. If the council just run it for themselves, they might as well run a private network, frankly. So it's in their interest to make it work. It's in their interest for every single one of us to have a wallet to start buying beer, wine, biscuits, cars, boats, whatever, with HBAR. Micropayments, all of those things, it's in their interest to do so.
Just curious, why did you set up in the U.S. versus and open yourself up for like securities law, tax, state issues? Like, why not structure it somewhere else?
So, to be honest, I don't know. I don't know. I have an idea, but I'm not legally qualified to say whether it's right or wrong. I believe it's something to do with the fact that founders are American, and therefore they had to set up in the US to start with. But I could be completely wrong on that. You'd have to, I mean, feel free to ask on our Telegram channel. There may be someone there more qualified to answer.
I have a question about your file system. You mentioned you can show proof of deletion, which is good for like GDPR. But on the other side, you also mentioned that each node holds a unique and complete copy of a file, probably secured with the private key. But still, let's say I want to get deleted, and at that specific moment, the node unplugs. Number one, it's not completely deleted, even though you may show proof of online nodes it being deleted. And the second thing is, if it was sharded in something like an IPFS system, right, not a full copy on each node, the node size would be smaller, and you could delete the shard, so a little fragment may not be worth anything. So can you just compare the two and why you do it your way?
So my understanding is that the reason we don't shard the files as you describe it is so that we have the asynchronous Byzantine fault tolerance properties all the way through to the file system, which we wouldn't have if it was sharded outside of the network. As an example, you're absolutely right. If a node temporarily goes offline, then it would not necessarily. It would retain a copy of that file. When it rejoins the network, it will resync, and those file contents will be deleted.
I guess the last question is just node size. Like, how do you stop nodes from them becoming 2 terabytes?
So we have a node specification for mainnet today, which has what we believe is a sufficient amount of storage. Again, the file storage on Hedera is more expensive than it would be on IPFS, clearly, because that's free, right? Or AWS or Google file storage. But the properties of the file system are fundamentally different to all these other platforms. As an example, although I can't say for sure about IPFS, one of the examples I often give is that if you and I entered into a contract and we wanted to record the existence of that contract somewhere and make sure that neither of us can modify the contract, because I don't trust you, you don't trust me, that's fair enough, we don't know each other yet. But we signed this contract, so we can hash this contract, we get a fingerprint of the contract, we put it on Hedera Hashgraph as a file, 48 bytes, it's barely anything at all, and we both put our public keys, so we both have to sign to put this document or this hash on the Hedera file system. What that means is that, so we have natively multi-sig on accounts, on files, and multi-sigs with thresholds as well. So if 3 of us entered into a contract and we agreed that 2 out of 3 can modify the contract, then we can set the keys up so that 2 out of 2 signatures are enough out of 3. So back to the original example, we both store that hash and we both sign it. Neither you nor I can change that without each other's approval. So we have proof here of the contract that we signed. However, 6 weeks from now, things have changed. We agree on different terms. So we take a new fingerprint of the new contract and we replace the original, both of us, we both signed for it, and the new contract is now in the system. Few months down the line, we dispute that contract, and we go to court, and I show them mine, you show them yours, the contract, and we extract the fingerprint from Hedera Hashgraph, we compare it to the fingerprint of both documents, and we can tell which of the 2 is the right one. So we know who's lying and who's not. So that's a really, really simple example of how you can use the Hedera file system with control mutability, where only the owners of the file can make a change to that file, subject to thresholds and so on and so forth. And this extends to smart contracts. You can put an administration key, or you will be able to put an administration key on a smart contract, such that if you're not comfortable with the notion of code is law, and by the way, DNA Piper, the lawyers on the council, disagree that this actually is the case. Code can never be law, but that's their business. You can essentially set it up so that given the right number of keys, and this could be an arbitration panel, arbitration judges, given their approval, the bytecode for the smart contract could be changed in order to fix a bug or alter a state and reset some data that has gone wrong through a history or through bug. I heard recently, or I read recently on a telegram that this could be used to revert transactions. No, it can't. We can't recover funds from somebody else's account that has been paid into them. But you could change the state of the smart contract. So you could arguably say, this ERC 721 token that you bought no longer belongs to you. But this is subject to arbitration, and this is subject to control mutability. It's not a free-for-all. And if you distrust the keys that are attached to this smart contract, you have a choice not to run it. It's also possible to run a contract or create a contract without any keys, and then it's immutable, it's the same as anywhere else. So that's how we differ from a lot of those other platforms. Sorry. So why wouldn't the file system grow immensely large? Because it'll be far too expensive to store far too much data. What will likely end up on Hedera is plenty of fingerprints, because frankly that's all you need to store to prove the existence of a file at a point in time. Actually storing the file itself on Hedera doesn't necessarily give you a great advantage. You can store it on S3, Google Compute, and use S3 and use Hedera to prove its authenticity. Much cheaper. Thank you.
So in that instance, would you see a lot of the Hedera community, if they want to use like a full decentralized file store, using something like IPFS?
Yeah, I mean we say it. You know, if you want to build a YouTube, go to Amazon. Don't use Hedera. But we have a partner who again did a podcast with us recently. Their game is to check the authenticity of pictures. Pictures to start with, maybe media later on. We see all these fake news, we see all these pictures that have been kind of doctored, that people claim are for real, and it's getting to the point where not content producers, but media outlets are under pressure to validate the sanctity of these pictures that they put up. So these guys are working on a way of fingerprinting media at source, storing a fingerprint of that media on Hedera Hashgraph, such that when it's displayed by a content delivery platform, they can verify in real time that this thing is the original, and if it's not, they can take it down. So that's one of the use cases using micropayments and those fingerprints, 48 bytes hash of file, where you don't need to store a lot. The file itself can be stored offline. You're just storing that fingerprint. So yes, we encourage people to continue using their usual cloud storage facilities and to just use Hedera Hashgraph for what it's adding value for, not just as a folder.
Oh, another question over there?
Yeah, my question was kind of more so, like, kind of a closing question for me is like, so looking 5 to 10 years down the road, like, where do you see Hedera Hashgraph playing its role? Speaking to what you're saying right now, is like, where do you see Hedera Hashgraph fitting in the tapestry of everything that exists in 10 years?
So that's a great question, and Lehman's vision is very much, beyond 5 or 10 years from now. Lehman and Mance, I should call Mance out as our CEO. Their vision is for a 100-year company. I know it's a tough ask in today's world, but their vision is long term. This is not a short fuse, 20-minute. We've had fun and let's get on with it. So the vision for 5-10 years from now is that Hedera becomes part of the internet fabric. On trust, on payments. There's so much wrong in the world today in terms of usage of private data. So giving you control over your private data, maybe even monetizing that private data, so that you can expose only the data you want to expose to third parties, that they can validate that the data you give that to them is valid by going to a third party for validation and using Hedera Hashgraph to do so, validating those pictures, as I mentioned. So, as far as Lehman is concerned, Hedera becomes a layer on top of the internet, that everything goes through to the internet or via the internet. So that's number one. Number two is one where, and I touched on those AppNets with the Hedera consensus service, is one where, and if you go back to Swirls, which is the company that launched the Hashgraph algorithm, Swirls stands for shared worlds. And Lehman's vision is very much that there is a world out there where if you and I want to have a chat over the internet, we can spin up an AppNet for that chat. And it's just between you and me. We don't go through a third party. We can run a game. We can run a Minecraft between the four of us without standing up a server, without attaching ourselves to an entity that's running it for us and we're paying money to or whatever. So those AppNets with the Hedera consensus service potentially become these kind of standalone worlds where we can all privately exchange information and do whatever it is we want to do, and maybe share with others if we want to. But we kind of take control of those elements of the internet. So that's Lehman's vision. So we'll hopefully we'll get there.
All right, I think that looks like all the questions. So thanks, Greg, for joining us for this talk, and we'll hope to see you back again sometime.
Yeah, thank you very much, everyone. Thanks for the great questions.
Thank you.